Welcome to the lecture of system design, everyone. And in this lecture, I'll be talking about a component for any kind of a scalable system. Again, there are thousands of components which exist to design this kind of a scalable system, which I'll be talking about. But here, with respect to one single use case, I will be highlighting all of those major components, not a minor one, as we are very new in a system design. So we have not discussed about those components, and those components will come into a picture in a later stage. So I'll be restricting myself just with respect to a high level discussion, and it's pretty much obvious that those who are completely new for any kind of a system, so maybe you will not be able to get a couple of words or a couple of things which I'm going to explain. But for sure, I'm going to give you an assurity that for sure you will be able to understand it once you will go through the entire lecture. That's the whole idea. That's the whole purpose. That to give you a very high level understanding, a very, very high level understanding, so that it is going to build a line in your brain that, okay, so maybe this is the approach. And then in a later stage, we can go dig deeper into it. And then we will try to understand things in a detailed way, all the alternative in a detailed way, all the options in a detailed way. So let's talk about this component with respect to a URI. I already talked about a URI a lot, and I believe you all have experienced a URI a lot so far. So here, if I have to design a URI, which we have already done that, and yes, URI is able to cater so many users on a daily basis, thousands and thousands of a user on a daily basis. So what are the core component that we have kept inside a URI? The very first component is basically a load balancer. As we all know that URI is a chat system, so which can receive a query from multiple users at a time, right? In a single second itself, it may receive a query from a multiple user. And again, it can't say that no, just wait for 1 minute, I'll answer your query. I'm answering someone else's query. It is supposed to give a response immediately to all the user, right? All the user. So how it will be able to do that? Because in a backend, there is a system, right? There is a system, so where it is supposed to do a computation. It is supposed to generate the answer, right? A major part is basically a computation. Now, this is where this load balancer comes into a picture. Now, what is this load balancer? So think in this way that I have multiple laptops, right? I'm going to explain you load balancer in very, very detail. We have a specific chapter for that. So where I will be talking about just a load balancer and how actually it works. I'll try to show you some of the demo example as well, that how you can configure it. So just think in this way that I have a multiple cluster of a system or cluster of the laptop. So we all understand laptop, right? So a cluster of the laptop, maybe like a 5 laptop or 10 laptop connecting together. Now, when one user is going to ask a question, so I'll send to one of the laptop, then other user is going to ask a question. I'll try to send to the other laptop. Then third user is going to ask a question. I'm going to send it to the third laptop. Now, each and every laptop is having all the idea about the application, a URI application, means what URI actually does. So parallelly, all of this laptop will give an answer to user number 1, user number 2, and user number 3, basically, right? User number 3. So in this way, I'm able to cater a multiple user all together, and that too without any kind of a delay, without any kind of a uplifted latency. Now, this is where load balancer comes into a picture. So where it is going to distribute means, so whatever load, whatever task that we have, so it is going to distribute those tasks among a different systems, system number 1, system number 2, system number 3, and so on, right? Across a multiple system, it is going to distribute and it is going to give an answer. So again, in a URI, so thousands of users are going to hit a URI platform in a single second or maybe in a single minute. So what it will do is, it's not like one system is going to give all the answer or to cater to all the user. No, it will be divided among all the different system, and system is talking to each other. System is in sync basically, right? And each and every system will try to cater to those responses, and whichever system will be free, by the way, right? Whichever system will be available, whichever system will be free, that system will try to cater to my user. Now that is possible with the help of load balancer. So we all try to configure. So wherever we are hosting our application, wherever we are hosting our backend services, right? So we try to configure in such a way that whenever there will be a high demand, means there will be a high number of query hitting to my server, it will try to spin up, and then whenever there will be a low demand, it will try to spin down, so that without giving me any kind of additional cost, which is not a genuine cost for me, it will be able to cater to all the user. So that is our first part that will come into a picture. That is the first component for any kind of a scalable system comes into a picture. So it doesn't matter you are going to design a Yuri or maybe some other kind of a system like a Netflix, Uber, Ola, or maybe a Amazon kind of a system. Everywhere you have to apply a load balancer. Strategy is going to be a different in a different situation, depends upon the number of user, depends upon the latency, depends upon the traffic that you are expecting, depends upon the application that you have hosted, the server that you have hosted. But yeah, at the end of the day, you are going to apply a load balancer, which is going to distribute your entire load or task among a multiple system. So instead of getting answer from only one laptop, only one system, now it will try to get an answer from a multiple one. As simple as that. Then there will be a application server comes into a picture. So application server means the server which executes basically a business logic. So for example, user authentication is one of the application that we have. So without authentication, you will not be able to access our Yuri. The another one is a tool calling with the help of MCPs, or maybe a model selection and routing with the help of with respect to the query of a user, that this query will be responded by this model, this query will be responded by this model, or input and output formatting. So because LLMs always try to provide you a raw input. I don't know how many of you are aware about it, but you just see whenever you chat with a chat GPT or Cloud or Perplexity, you always see a formatted response. But try to use LLMs via an API, you will be able to understand that it is going to give you a raw responses. And every one of us, including inside a Yuri, or whether it's a chat GPT, or whether it's a Cloud or whether it's a Perplexity, everyone is trying to format it. All these clients are trying to format the entire response so that you will be able to see a response properly in terms of a formula, in terms of a tables, in terms of a documents, or in terms of even a normal chat, so that my users should not face any kind of a inconvenience. And all of these comes from a application server. So we have written a different kind of a application which is going to fulfill that particular part. So load balancer is a very first component, a high level component. Application server is another high level component. Then databases. Without database, you can't design any system, whether it's a in-memory databases, whether it's a SQL system, whether it's a NoSQL system, whether it's a graph-based databases. Without database, no means literally you will not be able to design any kind of a solution. Now, there are not just hundreds, I would say, but thousands of databases which is available in a market, and that too in a different segment. On a very high level, you can try to divide it in a SQL system and in a NoSQL system. SQL means the kind of a databases which always try to store a data in a structured format into a tabular format by creating a schema. You must have seen a SQL, or in a layman way, if I have to explain you, Excel sheet, right? Excel sheet kind of a data. Now, there are some systems, so there are some databases, or you can say systems, so which is going to allow you to store a data in a document format. Means unstructured data, you can try to store it directly. For example, MongoDB or Cassandra. There are some system which is going to help you out in terms of storing a time-based data set as well. There are subsystem which is going to allow you to store a data in a graph format by creating a connections. So there are n number of a database which is available in a market, and all of these databases has been designed for a different purposes. So whenever you are designing your system, you should not go and apply a thumb rule that, okay, I have experience with a SQL system, so I will blindly go and use this SQL system, doesn't matter what kind of application I'm building. No, that should not be an approach at all. So here, inside Eury, if I'll talk about, so majorly we are using a PostgreSQL and we are using a MongoDB. Now, for what purposes we are using which database, right? So we are able to get a structured data. We are able to get a unstructured data. Structured data means your profile data. So whenever you are going to log in, whenever you are going to fill up your detail inside a profile section, all of these data set is called as a structured data for us. And there is a unstructured data. So whenever you are trying to do a chat, whenever system is getting crashed, whenever we are trying to generate a logs, or whenever we are trying to configure some sort of a tool. So it's a unstructured data that we are talking about. So we have decided that, okay, so if I'm getting a structured data, I'm going to keep it inside a PostgreSQL, which is a SQL based database. And whenever I'm going to get unstructured data, I'm going to keep it inside a document-based database or NoSQL-based databases, which is called as MongoDB. As per our previous experience with all the application that we have built so far, so forth. And both of this database, so PostgreSQL instances we have configured on AWS, and MongoDB we have configured with the help of like a MongoDB solution, which has been provided by officially by a MongoDB itself. So both of this solution or both of these databases provides us a replication of a same data in a multiple different regions, in a multiple different servers, so that it will be highly available. So even if one region is going down, data will be available in other region and it is going to respond back from the other region. And it will be like a highly available in that way if I'm going to replicate it. And both of this solution we have configured in such a way that it is going to support us. And again, it just depends upon our configuration. It's not like by default MongoDB will be like a highly scalable and it is going to create a replication. You have to set that parameter. Again, same is applied for a PostgreSQL as well, right? For all the databases out there. So this is the database component. Then the third component that we are using inside a Eury, a third major component that we are using inside a Eury is basically a caching layer. And for that, we are using a Redis. Now, what is called as cache, by the way, right? What is called as cache, by the way? So here we try to store a result of your chat or whatever tool or whatever activity that you have done on a Eury platform. We are trying to store it somewhere. Now, why? What is the reason? So that again and again, when you are asking a repetitive question, very frequently you are looking for a same thing, I should not go and hit my like a backend server. I should not go and like generate some sort of a response from a ground zero. What I can do is I can try to take a help from your caching system, and then so frequently I will be able to answer to your query without hitting my server again and again and again. And this is where caching is been used. This is where caching comes into a picture. So we are using a Redis for frequently used data or frequently used conversation inside a Eury. And caching layer is again one of the very much important layer for any kind of a system. Now, the fifth component that we are using over here is called as a messaging layer, right? Messaging layer. Now, what this messaging layer, by the way, does, right? Inside a Eury, and what we are using like a messaging layer. So we are using basically a RabbitMQ over here. There are other alternative like a Kafka. You can go ahead and use it. But yeah, so we are trying to use a RabbitMQ for this messaging layer. Now here what it does is that it will always try to handle a tool execution that takes a longer time, and it will be able to queue all the logs and all the analytics event that we are generating to monitor our platform. And yeah, so these messaging layers are going to ensure that without blocking any kind of a request from a user side, it should be able to give an answer. So this is where we are going to use our messaging layer, a messaging queue, and here we are using a RabbitMQ. Then the another component, a very important component when you are going to bring your system live to all the user, to all the world. something called as CDN, Content Delivery Network. So generally, when we try to create a system, so we'll be having some sort of a static file, right? Maybe images in general, right? Images. So again and again, and let's suppose I'm going to store my images into a S3 bucket, or maybe I'm going to store it into a blob storage, Azure blob storage. Now, so what happens in general is that if I'm going to call those S3 bucket, if I'm going to call my Azure blob again and again and again, then from a user side, it is going to take a lot of time. It is going to take a lot of time in terms of loading those images, and user experience is not going to be that great. So in general, what we do is, so whatever static data that we have, so we try to store it into a different content delivery network in a different region, so that locally it will be available, or as nearest as possible it will be available. All of these static file, or all those files which is not changing much frequently, which is not very much dynamic. So we are going to store all of these things into a content delivery network, so that it will be able to give a response to my user as soon as user is going to hit it again and again and again. Now, how we design it, which kind of a services we are going to use it as with respect to a content delivery network, I'll be talking about it. There is a specific chapter that we have just on a content delivery network. And then the another part is a data storage. Like I have already mentioned that we are storing our static file into a bucket, S3 bucket, by the way. We are not using basically Azure blob over here. We are using all the AWS stack inside a Euron. So in Uri. So here we are using basically a S3 bucket, and inside a S3 bucket, so we are trying to store all the information, all the static file, whatever file you are going to upload from your side as a PDF, or maybe as a images, whatever chat that you are doing, or whatever logs that you are generating or system itself is generating. Each and everything goes inside a S3 bucket, and that is something that we are using for a data storage. Now, the last part is a major part, right? So these 8 components are basically a major component which I'm trying to discuss with respect to this Uri system, which is a scalable system. So here for monitoring and logging, because there is a possibility that system may get crashed. There is a possibility that some of my users are going, in some of the reason, are going to face some sort of a disturbance, some sort of a high latency. So I have to monitor it. I have to build my system more and more scalable. Now to do that, I have to understand their problems. That who is facing problem, what kind of a user is facing problem, from what kind of a network user is trying to hit, what kind of a exploitation a user is trying to do. So I have to understand all of those things. Now to do all of those things, I need a monitoring layer. I need a system, so where I will be able to store logs, and I will be able to audit it. I will be able to process it, right? So that I can track a system performance, so that I will be able to detect any kind of errors or any kind of a failure, and eventually I will be able to debug, and I will be able to solve that particular issue without giving a lot of inconvenience to my user. Now, so we are using Prometheus and Grafana for dashboarding purposes and to generate all of these matrices, and we are using ELK, Elastic Log Stash and Kibana services, for a centralized logging inside a Uri, so that we will be able to monitor a response time. When we are saying that, okay, within maybe 30 millisecond, my system is supposed to respond. So is it responding to all the user? So that is something that we try to monitor. If you are going to integrate some of the MCP tool, so if it is going to fail, if it is going to succeed even, right? If it is going to succeed even. So in which case it is failing, in which case it is succeeding. So whether it's like an error from a backend side or maybe from a client side. Now to observe each and everything, we have ELK. With the help of that, we are trying to log it, we are able to monitor it, and we are able to debug, and we are able to rectify it. So these are the overall 8 component in general. In general, doesn't matter whether you are working in a Uri or maybe in some other system, but you will be able to find out. Now, I have talked about this 8 component, but I'll be talking about more and more, and that too with a multiple alternative, with a multiple provider, and with a design of these component that how this components actually works, how you will be able to configure it, which one is best in a market, what should be your alternative when you are trying to build XYZ kind of a system in depth, in detail in my upcoming lecture. As of now, I'm just trying to give you an overview so that you will be able to understand little bit, not much, right? Just a little bit about system design, that what goes behind the scene whenever we are trying to build any kind of a system. So with that, thank you so much everyone. Take care and see you again in my next lecture.